Hi, this is Jeff Bisty.
And this is Dustin Van Stee
with the Cognitive Systems Solutions Center. And today we're going to be taking a look at H2O Driverless AI. One of the things before we dive into the program itself, I want to kind of point out on their website, if you go into the products section of H2O.ai, you'll notice there's an open source platform called H2O, and the Driverless AI program is over here under Enterprise Platforms. These are two different things. The open source platform is not a free or watered down version of driverless AI. It is something completely different. So you have to make sure not to reference driverless AI as just H2O. If you go into a client site and say, we're going to be talking about H2O, they're going to assume you're talking about this. So even though it's kind of a mouthful, make sure you say H2O's driverless AI, because this is the one we're talking about. The great thing about this program is how easy it is to really install it. The whole name Driverless AI kind of describes it. Everything you need is contained within a single package. You can install it as a Docker image through an RPM, and you don't need any sort of prerequisites. You're ready to go. It's data science in a box. I have installed it on a system over here in the CSSC, and we're going to be logging into it through a simple web page. All right, Dustin, take it away.
All right, thanks, Jeff. So this is the Driverless AI web user interface. And when you start out with Driverless AI, the first thing that you're going to do is you're going to load a data set. And so you can see here that we've got a number of preloaded data sets, and I'm going to demonstrate how you'll use one. But let me just show you real quick. This over here on the upper right-hand side is where you would add a data set. You can see you could add a data set from a file system, upload file. We've got a connector to Hadoop file system and Amazon S3. So those are the ways you can load in your data from alternate sources. Now, we've already taken the liberty of uploading a data set. It's from Walmart, sales forecasting data set. We've just named it combined.csv. And I'm just going to click on that first row. And as you load in a data set, behind the scenes, Driverless AI is already working and crunching the data set. It's working out some descriptive statistics. So if you click on details, what it's going to show you is all of the columns that are in your data set and a lot of the statistics that you might want to know about it. So for instance, how many rows do I have of column C1, for instance? I've got 420,000 or so rows here. What was the mean of that particular column? Min, max, standard deviation. And you'll get that for all of the different columns in your entire data set. So if we go back here, there's some other features that are also available to you. You can visualize your data set. And in here, if you click visualize, what H2O Driverless AI is doing is it's preparing a number of different visualizations for you. And these are the ones that it's suggesting based on and analyzing your data. So if I click on the histogram data set, this is something that you would potentially have to write, some code in Python if you were using a notebook to be able to analyze the data and look at the histograms. Here, it's already prepared that for you. So it's really a quick way to understand what's in your data set. And you can slide through, look at the histograms of different columns here. There's a lot of other different diagrams that it provides you. I was just giving you an example there of one that you could look at. And if we go back, the final thing you can do here is create a prediction. So what that is it's really a shortcut. What you could do if you want is you could run an experiment. But if you run an experiment, you would have to specify new experiment. You would select the data source that you want, and you come here. This is really the same thing you would get as if you had clicked predict. So this takes us to the experiment panel. And as you'll see, the very first thing that you need to fill in is the system is queuing you to fill in the target column. So we're going to click on the target column. And we're going to select weekly sales because that's what we're trying to predict. Okay, so Jeff's going to review the experiment and expert settings, but before we go there, I'm going to cover just a few of the options that are available to you in this UI at top. And next we have dropped columns. And we happen to know that the column C1 is not a very predictive column, or it has no predictive capability whatsoever on the weekly sales, so we're going to remove that column from our analysis. Next, you have the option to specify a validation and test data set. What you would do is if you wanted to specify that, you would click that, and then you would have had to have preloaded the data set into the tool. If you do not select these, it will automatically create a validation and test data set for you on the fly. The fold and weight columns are some advanced features that might be useful to you when you're performing training. The fold column is useful when you might have a categorical feature that is fairly sparse and not well represented. And the fold column will help you, if you specify it, it will help you spread out those examples through your training, test, and validation set. The weight column is valuable in cases where you may have a situation where an example would be you had a survey come back from a group of 100 people, and you had another survey that came back from a group of 10 people. You may want to specify the number of people as being a weight column, so you might amplify a particular row more than another row. And finally, the time column is useful in situations where you have time series data. And for the Walmart data set that we're using, we do happen to have the need for that. So I'm going to select time column. I'm going to select date as our time column here. And you can see it's selected. So once you've specified your time column, the driverless AI software will also ask you for some more follow-on questions regarding your time series. And for this example, we're just going to use the automatic settings. But if you wanted to fine-tune this, there's a lot more that you could do if you just look within the help here within the driverless AI software. And with that, I'm going to turn it over to Jeff, who will take you through the experiment and expert settings.
Thanks, Dustin. And now we're getting ready to actually build our model through the launch experiment button. But first, I want to explain these three knobs and this column over here. We have accuracy, time, and interpretability. Accuracy, well, obviously you want a model that's as accurate as possible, but building a very accurate model takes longer, requires a lot more processing horsepower. So the higher I set this, the more features it's going to engineer, the more transformation it's going to do. So we don't want to do this unless we have a little bit of time set aside for this to crunch at that model. Time is a measure of how long it's going to bake those models before it determines the capability of it. Setting this number very high will lead to more consistent results, but there is sort of a diminishing return as I set this up higher. I might not need to set this to 10 if I'm getting the same results set at 5. So this is something definitely to play around with. And finally, the interpretability is how complicated do I want my model to be? If I set this to very high, it's going to try to build something that can inference rather quickly and is easier to explain than something set very low. It's definitely worth going into the help and reading the full details on what these knobs do. I've kind of just skimmed the top of these because, you're going to be spending a lot of time taking a look at these and determining how high you can or should set them. So lastly, we have this scorer column over here. There's a number of methods that we can use to determine whether our model is performing better or worse than the one that came before it. So there are various methods that people use to determine that, and you can pick through a number of them here. Down below, you can see that Driverless AI determined this is a regression type problem. It is not classification. If it were a classification type problem, we would have a different set of scorers over here. The reproducible button down here, we can select this and we can actually seed this experiment with a random seed value so that we'll get the exact same results if we run it with the same values and the same data sets. We don't really have a need to do that here, so we're going to leave that unchecked. Obviously, if our system has GPUs, we want to leave those enabled. That will make this run a lot faster than on a CPU-only box. So in Driverless AI, yellow means selected. We want that to be selected, otherwise it's going to take a whole lot longer. All right, with all those set, we are ready to go. We're going to click Launch Experiment, and it will start crunching. So you'll notice this funny looking name up here. Rather than just say Experiment 01 or Experiment 27, Driverless AI will generate a pronounceable name, which tends to be consonant, vowel, consonant, vowel, consonant, vowel. Just so you can kind of see, okay, that's mine. You kind of get used to seeing it. Or I can click this pencil here and give it my own name. So as you can see, the big wheel is spinning here. It's crunching away. It is trying to build a model. And it's not going to show us much until the first batch of results come in, which is what you can see right here. Three main things to be looking at is the iteration data. It is plotting the highest performing. We want the lowest number models that it's building. There's a few outliers up here. But in general, we want to see this bottom line, this trend line, heading down if we're measuring loss and up if we're measuring accuracy. In the middle right here, it's showing you which variables or transformations of variables it thinks are the most important in building that model. This is the feature engineering part of machine learning, and it's something that driverless AI does all by itself. And right over here, we can kind of get a couple snapshots of what the performance looks like. We can see, the mapping of the real numbers versus the predicted numbers, and they're kind of close. As it continues training, those will get closer. And we can actually click on GPU usage and see how hard driverless AI is driving the GPUs. You can see it's using them, but it's not relying 100% on them, which is why this is important to run this product on a system with beefy GPUs and CPU. It's going to use a lot of methods to try to build these models, and a powerful system definitely pays off here. And I'm skipping to the end here, but this is what it looks like when a model is done training. You can see it's 100% finished. I can download a summary of this experiment to find out how it arrived at the results it did. You can see the validation test score dropped down quite a bit from where we started. We have a new set of important variables, and there's a small summary going on over here. And that's really it. I have a model that I can export and run in a Python program, in a Java program, as a standalone Java scorer, or as a RESTful API. That's H2O driverless AI. Thank you very much.